Yeah.
Does that make sense? That's all right. So we're gonna inject this because that's how we roll. This is actually already going off, so I'm gonna shut up and just do this. So you can watch, sort of, probably not, this fill up, and you can see when this is full how the excess comes out that other hole, and that's what we want. You can also, you have to be really like, well, we're being gross. It kind of helps to burp it. Depending on how you set up your mold, all the air should want to leave it. And now this is, you were asking, what does pressure do for you? Actually, fuck it, let's just put it in the pressure chamber. What do you guys say? Woo! Somebody want to hold this? Somebody? Alright. Somebody want to grab that crescent wrench? I'm going to start tightening these down.
These crescent.
They are, but all right. Boom. Boom. We'll wait till we hear it. We can hear the air compressor running in the other room. Hopefully all the lights will stay on.
If the lights turn off, is it a good idea to run for the hills?
No.
You shouldn't drink that unless you're drinking another potion. All right, so in our big weird apparatus, we see some things going on. First of all, we see the temperature gauge over here, which has been going up the whole time. It will actually go up more during the course of this reaction. That tells us how hot it is in there. One thing that temperature does is it helps chemical reactions happen, and that chemical reaction will happen faster, which we don't need with this compound, but which is really helpful with some compounds. And because the reaction happens faster, usually the part will set up harder and nicer. It'll be more resilient when it comes out. We see this thing, which probably most of you realize is the pressure gauge, which is slowly going up. It reads out in kilopascals and pounds per square inch. I don't know if you use kilopascals, but probably a lot of people who are good at science. And pounds per square inch, which I usually arbitrarily have decided that 60 pounds per square inch is about how many pounds you should cast under. Mostly because it's safely under 110, which is what this thing holds. And it's plenty to put air in solution, which is why you cast it under pressure. So casting under pressure, which you had asked about earlier, somebody asked about earlier. So when you mix this stuff up, you'll look in here and you'll see tons of all right, we're not going to probably see much benefit from casting under pressure because it's probably already going to be set. But the benefit of casting under pressure is when you mix something like this, you get a ton of bubbles in it. The nice thing about pressurizing something is all those bubbles are squeezed down super hard. They're usually squeezed down hard enough that they go into solution. Like you guys have heard about getting bends when you come up from the deep. And then that's when you get bubbles in your blood because oxygen that's in your blood turns into a bubble. It comes out of solution and goes into a bubble. You're doing exactly the opposite thing. Whatever, yeah. Some shit and because you're not good.
Like a water bottle on an airplane?
Yeah, same thing. It's all water bottle, airplane, scuba diving, whatever. It's
what happens to water bottle on an airplane?
It goes.
I never tried that.
Like if you close water bottle before you take off, it goes like up in midair and then it stands back 30,000 feet on an airplane. Anyway, so that's what the bubble does. It gets.
So anyway, the idea is there that not that you get rid of them. Well, it would be great to not have bubbles, period, in your plastic. But since that's harder to realize, if you get rid of the bubbles if you put the bubbles in solution while the plastic is still liquid and it sets up, they'll stay dissolved. They won't ever turn back into bubbles again because the plastic is too hard. You get into weird stresses that puts on rubbers and plastics sometimes when you do that sort of thing, but usually that doesn't matter. In an ideal world, if you're really good at this kind of thing, you degas all that stuff first and use a vacuum chamber to do that. But that's usually, it's finicky, it takes more time. As you can see, because I was jacking my jaw, we didn't really even have time to pour that right. So a lot of the time, I don't know, different mold makers work different ways, but a lot of the time if you're going to skip a step, it's the vacuuming step. So hopefully, if we were fast enough, when we pull that part back out, we'll be able to look at this and say, aha, look at all those ugly bubbles in there, but that perfectly clear part that's in there. Based on how fast it's set up, I don't think we're really going to see that.